Supposed to get his picture. Let me share screen.
And then you would pitch it.
I remember a lot of it.
You gotta do it just fine.
No, that's.
It's fine. What? You gotta do it just fine. Better.
Did you stay up? Next.
Yeah.
What time's that?
Good. Ready to rock and roll with recording. So.
Good afternoon. My name is Travis Posey, and I serve as the Western Hemisphere Sales Manager for Rotoscope Flying System. We are a company that you may have never heard of, but we are an awesome company. Let's get started. Rotoscopes originally, just most of all the companies inside of Bankview was once a part of GE. So we were the product line inside of GE, strictly dealing with the gas turbine and being able to have plane system technology for the gas turbine. We're in Twinsburg, Ohio, which is south of Cleveland. So this is north of Cleveland, so we're south of Cleveland. So we have a staff of about between 150 employees. We have an engineering staff, physics, chemistry, electrical, electronic engineering, and we are a facility that pretty much cater to our customers. And we'll be able to, as based on plane system technology, we're able to be able to find solutions for you. UV flame system. You may have heard as flame system as several names. As fire, flame eye, flame system, combustion, flame monitoring, stack system. Overall, we are a harsh environment system. There are several systems on the market. And most of those systems on the market are operated at a certain temperature, at 70 degrees Celsius. We are a specialty type sensor because we can go up to 325 degrees Celsius. All right. One of the things that we do very well is this. This is the traditional part of our sensor, which is the flame tracker. This is the sensor that on every GE gas turbine that GE makes now. And we have graduated up to F-degree 825 sensor. And they are named based on their temperature. So this is 325 degrees Celsius, like 717 degrees Fahrenheit. We created a new burner-only sensor for boilers and volatile applications, which go up to 120 degrees Celsius. What we would like to understand from customers is if there is an environmental issue for the sensors, or they have a failure for the sensor, if so, we are a company that will have solutions for you. As I mentioned before, there are several solution sensor companies. So we thrive in an area where the harsh environment or customer having issues. And we are especially have the ability to work in high vibration area, high temperature, and hazardous area. And one of the things that we are really famous for, and I consider this famous for, is that we're able to custom design any offering based on our current technology of our flame tracker light, flame tracker drive 325, to ultimately be a part of the solution that you may have issues with. As I stated earlier, we started off as a gas turbine sensor company, mostly for all the GE heavy gas turbine derivative companies. Now we are more into new development. Our goal for Rotoscope is to be, in the next 10 years, be a 60% company outside of gas turbine. And we think that we can do that by the use of technology. So if you look at boilers, there are several boilers on the market, pocket heater, boilers, and dryers. This is a picture of a steam methane reformer. We're also very good in that area because this is a top fire steam methane reformer, and those burners are at the top of here. The furnace is below here, so heat rises. So right now, there's a lot of issues with flame sensors being able to survive in this environment. We have a solution for you. We are very successful in that. Customers have been coming to us because we are very competitive on prices for their performance and reliability. If you look at our previous development, as I mentioned, 6% growth. There is a big need for production flare monitoring for the pilot and for the final flare. We think that we have a solution in the future. We are working on development as we speak now. We would love to be able to partner with a company that may have issues now. We think that we have a solution that would be advantageous for the issues that you might have. Are there any questions as far as where we stand as a flame sensor company? No. So as I mentioned before, this is a two-part hit home run series today. My counterpart, Michael Spaulding, will come up with the safety of these products.
Thanks, Travis. So the primary value that we're going to bring to the customers is really around safety. Flame sensors are there to provide, a safety sensor. Oops.
You're right.
So we started out with gas turbines, and I know that a lot of the focus here is not around gas turbines, it's around burners, but this is significant because of the environment where we started. Gas turbines, the environment is extremely harsh, very, very high vibration, temperatures as high as 280 degrees C, and high pressure. So we've been operating, our sensors have been operating in that environment and giving good reliability for over 26 years. We counted up all the installed sensors that we have out there, and we have over 500 million operating hours. And with all of that, we have a product that's providing extremely good reliability in a very harsh environment. At the same time, we have very good fuel flexibility. This is an ultraviolet sensor, and we can sense the flame, of course, with natural gas, but also the sensors are used on naphtha, distillates, crude oil, diesel oil, you name it. So this can be applied to a lot of different fuels. It is not susceptible to black body radiation. It's a UV sensor. It's not going to detect visible light or infrared, and that makes it very, very fast. So we have taken this and applied it to other applications. We have a new product, FT Light, that this sensor is intended for burner applications. Burner applications are going to be a little less harsh, right? So we were able to take the same technology and quite easily make a burner sensor. The maximum temperature is derated down from, let's say, 150 C on the previous sensor to 120 degrees C. The pressure is derated a little bit, things like that. But at the same time, this is a much more rugged sensor than anything that's commonly used for burner applications right now. Most of the flame sensors that are used for burner applications, you're going to have a maximum operating temperature of 70 degrees C, 80 degrees C. For those applications where it's a little too harsh, and then there are those applications. Sometimes customers are having to apply insulated site tubes. They're having to add extra purge air or even dedicated compressors and cooling air and cooling sleeves. Well, that really takes and puts the burden on the customer to keep the sensor alive. And I think it's a much better idea to have a product that can handle the application, that can handle the harsh environment, and take the burden off the customer. And that's what these sensors can do. Again, this is the FT Light. Main value behind this is increased temperature. It's very rugged. It's built like a tank. Installation is simple. It's a 4 to 20 milliamp current device. And also, ends up being very cost effective. And we've had some very good feedback from our customers lately as far as how it stacks up in that way we've done. This is a burner application, but it is an extreme temperature application. Steam methane reformers, the type that have the top fire design, those have very, very high temperatures. The penthouse that's up above the firebox, the temperature up in the SMR penthouse can go very high. We know, because we measured, the temperatures can exceed 150 degrees C right at the burner front. So there are customers out there, there are people out there that don't know that there are options. They've tried other flame sensors and did not work out, and they've just gone without. The Architecture in Belgium is a good example of that. In 2011, they were rebuilding their methane reformer after an accident. They installed flame sensors on there. Those flame sensors were not able to handle the environment, and they died. And the customer just ran for years without any automated flame sensing. We worked with that customer and showed them that our sensors can handle the environment. They installed a full set of FTD 325s in the penthouse in 2018, and those sensors are still out there providing very good reliability, including a number of restarts, which is the most critical time for the steam methane reform. What I want to illustrate here is we have options no matter how extreme the environment gets. Starting out, we have the Flame Tracker Lite. That will work for a lot of burner applications, and it's still going to be well beyond the maximum operating temperature of any of the competition that's out there. But if there is an application where the temperature goes beyond that, we have options. Flame Tracker, that has a maximum operating temperature of 150 C, and if it's an extreme environment, we can go to the Flame Tracker Dry 325. The hot end of the sensor here will operate up to 325 degrees C. Of course, we have all the hardware and everything to help on the installation. Now, looking forward more to energy transition and a lot more focus on emissions. Well positioned there with this technology. Starting out, our sensor has been tested. I know a lot of people are interested in using hydrogen as a fuel. That may start out slow with low percentage hybrid fuels. Our sister company, Turbo Machinery Process Solution, they did a couple of different tests on rigs, and you can see here how they transitioned from straight natural gas and gradually up to 100% hydrogen. And the output of the flame sensors stayed steady, still able to detect the flame as they move up in those greater and greater percentage of hydrogen hybrid fuels. So that positions this technology to perform well as we move into the hydrogen economy. The intent is for different industries to use hybrid fuels for decarbonization. I know that there's been hybrids from 5% up to 80% out there in industry, and SMRs would be a good example of where this could help. We know that SMRs are going to be key. The blue hydrogen that comes about, it's going to be steam methane reformers in combination with carbon capture and sequestration. And if they are using hybrid fuels, then our sensor is going to be able to detect flame and increase safety on those applications. Gas turbines is another one. Gas turbines are going to be around for a long time. They are a dispatchable energy source that is used today and will continue to be used to support renewable energy. You dispatch the gas turbine when the sun or the wind is not available. And this is where we've already seen gas turbines operating with hybrid fuels, and our sensors are on those gas turbines and operating very well. So a lot of the focus in developing this hydrogen economy is not, to make the technology, but to make the technology cost competitive, to make it make sense economically. And I think one way one thing that's going to be important in that is you got to mitigate the risk, keep these things safe, to keep the costs low, and that's going to be one way that do our little piece here to enable the hydrogen economy. One other thing looking forward, we have just developed a new flame sensor. It is a fiber optic version of our FTD 325. So here at this end, this is just optics for light collection, and then the light is transmitted through the fiber optic cable back to the sensing element and the electronics in the sensor body. This allows us to have a lot more flexibility with sensor length, and also it's a more user-friendly material, the fiber optic cable. We are going to be applying this to flares. We are working with a customer, and the plan is for this year to us to be taking our new fiber optic sensor and to adapt it, do some initial testing, and then adapt it to monitor the pilot flares. In this way, you make sure that your pilot is on, you can avoid accidental methane, natural gas emissions.
Are you able to also detect sort of percent or combustion percentage from that?
Right now, no. This sensor will give you a 4 to 20 milliamp output that is proportional to the amount, to the intensity of the light, right? And so you set a threshold and say, well, above this threshold, the flame's on or off. However, this fiber optic cable does enable us to go further and then take new measurements. You can bring the light back to the electronics, then you can make different measurements with the light, and then you can get into analytics, looking at the spectrum, things like that. And that, I think, is very promising. We are already doing development on that front. It is early days, but it's looking very promising, and we want to move out into a lot more new measurements. But this is part of enabling that progress to get to those type of measurements.
Excellent.
What advantage do you see of having that?
So we've been getting a lot of requests from customers recently around percent burn, basically, with not just flares, but also things like exhaust, like from turbines and things as well. And they actually, so there's two problems. One is the one you solved already, which is pilot lights on and off, which I used to think it would be easy because I had to look at it, but it turns out you can have like 5 pilot lights up there and like 3 can be on and 2 off. It's a little harder to see.
Right.
So that's one problem that they're looking to solve. So that's fantastic to hear that we've got a solution around that. And the other one is, like I said, that percent, how efficient is it actually? What's the burn? And so we can, obviously with Flare IQ, we can predict what it should be, but the back end of that is checking that that's actually what's happening. And then in some cases, like I said, like turbine exhaust and things like that too. So I've got a couple of customers that might be very interested in that. And we can figure out how much actually, what additional development work. Who's are you the product manager on this, or?
The product manager is Chris, which is not here. Might be
Okay.
the
Application engineer.
Okay, all right.
So, and once you can look at the full spectrum of the light coming off of the combustion reaction, then you can learn a lot more. And we have a whole slew of measurements, including the type of thing that you're talking about, that we want to make happen, that we have interest on the gas turbine side, and certainly that makes sense that your customers are interested in the same things.
Yeah, no, we should definitely.
And then I think the path is to solve the gas covering problem first, and then we can use that to put on the flare.
I think that right now, our development, our NTI development is going on with cooperation of Turo Machinery Process Solutions, as well as our very large customer, GE Power.
Yeah, okay. No, we should, there's a few different conversations, around it, and it's always challenging to piece out who's curious from a research perspective and who wants to buy a album, you know?
Right. And that's true, and I think both of them are thinking about their new build, but you know, that everybody also is keeping in mind that large install base that they both have, right? And how that will work.
Yeah, if you got some customers that want to do a trial period, we could trial some things that
Yeah,
come up with
might
an
do.
agreement, right? And then we can help develop it.
I
Be
might do.
another data point for us, Mike.
Yeah.
So one of the big things you'll find with players, especially the big players, not the little players that you work with, is to that efficiency, that closed loop side, they're using a lot of cameras, manufacturers of here. So if you walk around and try to find out what the core method that they use, one of the advantages something like this has, if you get that broad spectrum, is that you are close to the flame. With their very much stood off most of the time with ground level. So if you have a fog or if you have a storm that comes in, they're going to not be able to do very well. But you know, in a clear day, they're going to do very well. Even at nighttime, they'll struggle a little bit. Something like this can overcome that limitation. It might be more cost effective, but you definitely need. It's not you looking at a point. You got to look at the full spectrum. You have to be able to do those calculations and understand it. But using that as the closing up of the open loop, where I view it, be a complete solution. Some customers are only using the camera because it's closed loop, and that's what their mindset is. And some customers see what player like Hughes does for them, but in the upstream market, it doesn't make so much sense as an upstream market. By providing gases.
Yes, and that makes total sense from, you know, the ability to start, you know, putting measurements onto actual flares. I think the ability to try things out is going to be a lot easier on the upstream side, on the production wells, getting that kind of experimentation in very large downstream flares, you know, physically installing things on those, it's going to take some time. So maybe it'll work out that we cut our teeth on some of the smaller things and show value there.
I think what I love about this too is the continuous piece of it, right? So with cameras, unless they're using fixed cameras, it's a check, but it's nice with the continuous piece as well.
And there's going to be a good bit of mapping here on what is the temperature where and how much light do you get at that point, and the optics, you know, we'll have to adapt our optics to where we're getting sufficient amount of light. So just the whole configuration of where it is and what the optics are, I think it's going to need some customization.
No, makes sense. Sorry, now I'm distracted.
Oh, no, I like the new conversations. That's great. That's awesome. Yeah. All right. Thank you all very much.
Cool.
Oh, you're awesome.
I come to Austin to find out what you guys are doing in Motor Street and to find out that, wait a second.